As we discussed in the last chapter, QTP is storing information about objects, the classes they belong to and their descriptive properties, but this information is not shown in the script. We use the Object Spy to have a look at some of this information. We're now going to see where QTP stores the information. This is in an entity called the Object Repository. We can access this either via the toolbar or off the Resources menu. Here, if I select Resources, Object Repository, we can see the information that QTP has captured about the objects I recorded against. Here's the Object Repository, and as you can see, we have entries in it that look very much like our script. Each one of these is a test object, and it stores information about the class of object and the descriptive properties that QTP is going to use to identify the object in the application. An important point here is that objects are always recognized in relation to their parent objects. So at the top of the tree, on the left-hand side in the Object Repository, we can see the flight reservation window, just like we do in the script. And then underneath the objects that are children of that parent object. If we want to see what these objects are, I can select one, such as the Insert Order button here, and off the toolbar in the Object Repository we have a Highlight in Application button. If I click this, we can see it flash in the application. This means that QTP can recognize the object in the application from the description and highlights it to show us. The Object Repository allows us to add objects, to modify their descriptions, or even delete objects. Just to show you how important the Object Repository is, if I delete all the objects from it, here I'm just deleting from the parent window, so all the child objects will be deleted as well. Now there is nothing in the Object Repository. If I go back to the script and I start refreshing the information you see here just by clicking on the objects, you can see that the icons that denote what class the objects are has now disappeared and is replaced by a question mark. If I try to run my script, QTP immediately recognizes that there's a run error. It cannot find the objects in the Object Repository. So for every test step within QTP, QTP is looking up the object description within the Object Repository. And if the objects aren't there, then the script won't replay. So let's start a new script and see how the Object Repository works. I've started a new script, and you can have the Object Repository open while you are recording or playing back. So if I open the Object Repository, we can see that currently there is nothing within the Object Repository, as this is a brand new test. I'm just going to try and reposition the application so we can see both the Object Repository and the application under test, as well as the script. I'm going to record, and if you keep an eye on the Object Repository, you'll see as I start recording against my application, every time I perform an operation on an object, the information about that object is captured and entered into the Object Repository. And then the script statement is generated. So it's going from the application to the Object Repository and then to the script. For every object I manipulate, QTP is capturing the object class and a description of the object. in order for it to be able to identify the object again when we play the script back. I've finished recording, and you can see that the object repository has now been populated. So let's have a look closer at the object repository and what is stored within it. If I click on the objects, on the left hand side we have the name of the object, in this case flight reservation. We can also see that on the right, name, flight reservation. Underneath that we have the class of object, in this case a window, the repository that is stored in, currently we're focusing on local object repositories, and then below the description properties, and this is what's being used to identify the object in the application. If I click on some of these other objects, such as these win buttons or win combo boxes, you can see that over on the right hand side the description is quite short. In this case, the native class is a combo box and its attached text label is fly from. If I highlight the object, we can see that's the fly from combo box in our flight reservation application. If you remember, when we were using the object spy and we spied on the fly from combo box, we could see a huge array of properties and values, so a large description of this object that QTP can see. However, QTP doesn't need to use all of the properties about this object. In fact, it wouldn't make sense to use many of these properties, such as the absolute X, the absolute Y, because those are likely to change. They're dynamic. If I move the window around, then the position of these objects is going to change. Same with other properties such as the Windows handle, which is also dynamic. So QTP only uses a subset of those properties, the minimum static information that it can use to identify the object. So in this case, the fact that it's a win combo box and its attached text label is fly from is the only combo box that matches that description in this window. So that's all the information we need. Same with some of these buttons. If I click on the insert order button, here we can see that the class is a win button, and down below the text or the label is insert order, native class button. And that's because this insert order button is the only button within the parent window that matches that description, that has a label of insert order. So that's the only information that QTP needs to store about that particular object. Now when we replay our test, it does the opposite. For every test step that gets executed, such as the first step, activate the flight reservation window, QTP looks up the object in the object repository. So in the object repository, it finds the object with the same name, flight reservation, and then looks at the description. So the class is a window, takes the full description, the property values on the right hand side in the object repository, and uses that information to identify the object in the application under test and then perform the step. So it's the reverse of recording. When you play back the script, it simply looks up the objects, accesses the description of the object and uses that to find the object and perform the step. If it can't find an object, then QTP will pause the script and tell you. The easiest way to think of the object repository is as a lookup table. The object repository provides descriptions of all the objects within the application that are used by your script. And QTP looks up these descriptions in the object repository, takes the description and then uses that information to locate the object in the application. The names of objects that we see in our script, which we also see on the left-hand side in the object repository, are completely arbitrary. It doesn't matter what the objects are called, because it's the information on the right-hand side that is important. As an example of this, the first statement in our script just says button click. Well, if I locate that object in the object repository, here it is, here's the object called button, and I click the highlight button, we can see in the application that it's the new order button, the first button on the toolbar. So the name is not very appropriate, but we can rename these objects. So over on the right hand side where it has the name of the object, or you can click in on the left hand side and rename the object, we can give the object a suitable name, such as new order. I've changed the name of the object as it appears in the object repository, which has also updated the script. We can see over on the left hand side in QTP, the actual test script, the object is now called new order. And if I run my test, it still locates the object and clicks it, because it's the description that it uses in the right hand side of the object repository to locate the object. Just to highlight the point again, here's the insert order button. If I click in there, I could change the name to Edgewords, for example. It doesn't matter what the object is called as long as the name of the object in the object repository matches the name in the script. Because QTP, when we play back this step, is going to look up an object called Edgewords, which it finds in the object repository, and it then looks at the description, that it's a Windows button and its label, its text property, is insert order. Well, there's only one button in this application that has a label of insert order, so it can easily identify that object and then perform the step. So the names of the objects really are just aliases to be able to look up the objects in this object repository, in this lookup table. If I play the script, my script still plays back successfully. Now QTP derives the names of objects from their text label or their attached text label. If it can't find an appropriate name for an object, because there is no label, then it will call it whatever the class of object is and just put a sequential number at the end if there are more than one. So if you record a script and you don't like the name that QTP has assigned to objects, you can always go into the object repository and rename objects. In the final part of this chapter, we'll talk about editing objects in the object repository. If I open the object repository, as we've already demonstrated, we can rename objects. So again, here's this button that I renamed to Edgewords, and I can change the name to something more appropriate, such as insert order. This will also update the test that we currently have open. As you can see here, it's renamed the object to insert order. We can also learn new objects. So from within the object repository, one of the toolbar buttons we have is to add objects. If I click on this button, the cursor changes to a hand, and then I can click on an object. QTP asks me if I want to learn this object or if it's the parent I'm interested in. Well, in this case it was the button that I'm interested in, not the window, the parent object. Click OK, and you can see that that's added the object to the object repository. So here's the delete order button, and over on the right hand side it gives me the class of object and the description. Currently that's not being used in the script, but Later in the course we will start adding objects and using them from our scripts. We've seen that we can highlight objects by selecting them in the object repository and clicking the highlight button. We can also update object descriptions from the application. To do this, we choose this toolbar icon, the one next to the Add Objects, and then select the object that we want to update the description of. This will recapture the class and the description property and values.